Hi, this is Nirmala Rednam. In this video, we are going to discuss parallelograms from Understanding Quadrilaterals NCERT textbook class 8. So, what do we mean by a parallelogram? It is a quadrilateral which has two pairs of parallel lines. A parallelogram is a quadrilateral which has two pairs of parallel lines. Remember, we started with trapezium. This chapter, we started with trapezium which has one pair of parallel lines. Whereas for a parallelogram, you need both pairs to be parallel to each other. Now here they have given a few examples. You can quickly check that these are parallelograms, whereas these are not. Here this, you will see that it does have two pairs of parallel lines, but it's not a quadrilateral in the first place. Therefore, this is also an example of polygon which is not a parallelogram. Okay. Now they're asking you, is a rectangle a parallelogram? The answer is yes. Rectangle is a parallelogram because it has two pairs of parallel lines. Now here they have given an activity to understand parallelograms more intuitively. You need two strips of different widths, and if you draw the outline of it, the overlapped region is a parallelogram. Let's do this activity quickly. So here I have two cardboard strips, right? They are of different lengths. I am going to draw the outline on a sheet of paper. Okay. So this is my first strip. Right? And then the second one I'm going to place in a slant position, and then I'll draw the outline. Now you can see that this is my overlapped region, and if I have to name it A, B, C, D, you will see that ABCD is a parallelogram because it has two pairs of parallel sides, right? So this is the activity that they are suggesting to check a parallelogram. Next, moving on, they have given a formal definition after that, saying that a parallelogram is a quadrilateral whose opposite sides are parallel to each other. We will come to elements of a parallelogram. Now, you know that any quadrilateral, for that matter, it has four angles and four sides, right? So you know what the opposite sides in a parallelogram are, what are the opposite angles in a parallelogram, right? And then you have adjacent sides of a parallelogram and adjacent angles. Now regarding the first property that they want to discuss, they have given us an activity where you have two congruent parallelograms, okay, and then you will be using them in order to check this property, which is the opposite sides of a parallelogram are of equal length. Okay, in order to check this, we will be doing this activity, right? So let us first take, I'm going to take two congruent parallelograms, the cutouts using two different color sheets. Okay. So what I want to do is, I already have two different color sheets. I will place them one over the other like this, right? I'll use the same cardboards again that I already have, the strips that I already have. Okay. And I will use one of the edges. It will make my cutting job easier. Okay. So this is one pair, and then put it in a slanting position, right? So that I have my parallelogram. Can you see this? Yes. So this is my parallelogram, right? So now quickly let us cut. Right. So okay, and this side. The second parallelogram is also simultaneously getting ready because I have overlapped one over the other, right? So yes, these are my two parallelograms. I have to name them. They have named it A, B, C, D and A dash, B dash, C dash and D dash. So let me name it A. Can you see this? Yes. B, C, D. Okay. And then I have A dash, B dash, C dash and D dash. Right. These are my two parallelograms. Okay. Now let us look at what they're asking us to do. Here they're saying that place A dash B dash over DC. Okay. I have these two parallelograms ready, right? Now they're saying place, can you see this? A dash B dash. They want me to place A dash B dash over DC. Okay. And then check if they are coinciding. If they coincide, that means what is the conclusion we are going to draw? Let us see that. Okay. So here I have A dash B dash, right? This is A dash B dash. Now if I place it over DC, this is my DC, right? Can you see this? A dash B dash, if I place it over DC, it is going to coincide exactly. What can I conclude? I can conclude that A dash B dash is equal to DC, right? And you know that A dash B dash is the same as AB because these are congruent. I mean, that's how you have taken the cutouts. These are congruent parallelograms. That means that AB is equal to DC. Opposite sides of a parallelogram are equal in length. Similarly, you can check that. See, this is AD. A dash D dash is nothing but the same length as AD. And now you can see that A dash D dash is equal to BC. That means AD is equal to BC. Now this is proving it by an activity that in a parallelogram, the opposite sides are equal in length, right? Next, what are they saying? They're asking us to verify the above property using set squares, right? Verify the above property using set squares. Let us do that also. So now here I have set squares, the 30, 60, 90 angle set squares, right? And if I place them along the hypotenuse of its right angle triangle, I get a parallelogram, right? I get a parallelogram, and in fact it's a rectangle because this angle is 90 degrees. So all the four angles are 90 degrees. Now here, if you know that this length, okay, is equal to this length, you have the markings on the set square, and similarly this length is equal to this length. That means in this is special case. In this parallelogram, you can verify that the opposite sides are of equal length. Okay, so that is another way of checking it. And then you have the geometrical proof for it. Now what is it? What is a geometrical proof? What we are going to do is take a parallelogram and join one diagonal. Okay. After joining one diagonal, we are going to prove the congruency of these two triangles ABC and ADC, and then using that congruency, we will prove that the opposite sides of a parallelogram are equal in length. Now let us do that. So we are naming the angles here. As you can see, we have named the angles 1, 2, 3 and 4, right? Now, if you look at triangle ABC and ADC, what can you say about the angles? You know that AB is parallel to DC, okay? So, if I consider AC as my transversal, then angle 1 and 2 are nothing but interior opposite angles, right? Interior opposite angles. And what do we know about interior opposite angles? They are equal in measure, okay? Interior opposite angles are equal. Therefore, angle 1 is equal to angle 2. Similarly, if you take BC and AD as your pair of parallel lines, and if you take AC as your transversal, then angle 3 is equal to angle 4 again. Why? Because they are interior angles. So the reason here they are asking why. The reason is these are interior opposite angles. Okay. And when you have two parallel lines, you already know the properties. Interior opposite angles are equal in measure. So now here I have two pairs of equal angles, and this AC is a common side. That means that by ASA congruency, I can conclude that ABC is congruent to CDA. Now here please keep in mind the order in which you mention the triangle. If you are saying ABC, angle A is corresponding to angle C here, right? In the sense that angle 1 is equal to angle C. So your second triangle should start with angle C. And then the angle B here corresponds to angle D in the second triangle. So I will take the second triangle as CDA. So you will say that by ASA congruency, these two triangles are congruent, right? Now, because these two triangles are congruent, I can conclude that AB, okay, AB is equal to BC. Why? Because now see, in the first triangle, AB is opposite to angle 3 and DC in the second triangle is opposite to angle 4. These are the corresponding sides. So AB is equal to CD. Similarly, BC is equal to AD. Therefore, we have our proof for the property that opposite sides of a parallelogram are equal in length. Okay. So they have given an example here. They have given only two sides. They want the perimeter. You know that if this is 7, this is also 7. And if this is 12, this is also 12. Therefore, you have 12 plus 7 plus 12 plus 7, which is 38 centimeters. You can quickly check that. Okay, right. So that is about the first property. Next, coming to angles of a parallelogram. Okay, here they have given an activity of taking two cutouts. You already have the cutouts ready. You have to place them one over the other, pin them together at the point where the diagonals meet, and then rotate one by 180 degrees. Why are we doing this? We will look at the activity and try to understand. Okay. First, I need the point where the diagonals meet, right? So let me join the diagonals here. Okay. So this is one diagonal, right? And this is the second diagonal. And in the second one, this is the first diagonal and this is the second diagonal. Okay, and let me name it O and O dash. So these are the points at which I'm going to pin them. Okay, and then we have to rotate them. So I need a base. Let us take the maths textbook. Okay, now I have one over the other. I'm overlapping one over the other. And then I'm going to pin it. So I'm using this pin here. Okay, I'm going to place it over the point of intersection of the diagonals. Okay, I'm going to place it like this, and then I have to rotate it by 180 degrees. Now, in order to use, let me use this line as my reference. Take it. I'm going to use this line as my reference. Okay. Now, you can see the parallelogram below is intact and I am rotating the parallelogram that is above. Okay. Now, this is 180 degrees, right? Because I've used this as my reference, the yellow line here on the textbook, right? So, this is 180 degrees. Now let us see what they're concluding from this. You can clearly see that these two parallelograms are still coinciding. Okay, they have actually used a transparent one for the above parallelogram. You can do the same. Okay, and you will see that the vertex here is C dash. Okay, this vertex is C dash and this is A, right? That means angle A is equal to C dash, which is equal to C. That means opposite angles are equal. Similarly, you can conclude that for all the four angles. Using them, you will say that opposite angles in a parallelogram are equal in measure. Okay. So here I have the property opposite angles of a parallelogram are of equal measure, right? This is my second property. Now again they have used the set squares in order to kind of see that this is true for the case of set squares. So I'll show you that. Take two identical set squares from the parallelogram as before. Does the figure obtained help you confirm that? We've already seen it. Let us. So this is my parallelogram, which is in fact a rectangle, and here you know that the opposite angles here, these two opposite angles are 90 degrees, these two are also 90 degrees, 30 plus 60, 90, 30 plus 60, 90. Therefore, opposite angles for this specific case is also true, that opposite angles are equal in a parallelogram, right? Now next, they are using the geometrical proof. Okay, so we have already proved that ABC is congruent to CDA, right? We have proved ABC is congruent to CDA. So now using this, how do you conclude that the angles, opposite angles are equal in measure? Now if you see here, this angle is equal to this, right? So for example, if I call this X, this is also X, and this angle they've already given, okay, is equal to this. You have to look at corresponding angles whenever you have congruence. So angle A is equal to angle C, angle C here is equal to angle A here. When I say angle A, corresponding to this triangle, and C corresponding to this, right? So these two are equal. I'm going to name it Y. Okay, so what do I have here? In the parallelogram, angle A is nothing but X plus Y, and in the parallelogram, angle C is equal to Y plus X. Correct? So this means that these opposite angles are equal in length. Similarly, you can do the same for B and D as well. Okay, so this is the geometrical proof. Now here in this question, they have given a parallelogram and they're asking us to find X, Y and Z. Clearly, if this is 100, X is also 100, opposite angles. And if X is 100, this is nothing but the corresponding angles if you consider TS and BE, right? Therefore, this is also 100 degrees, right? And if this is 100 and Y and Z forms a linear pair, therefore it will be 80 degrees, right? Because SE extended is a straight line. Therefore, you have Y plus Z is 180. This is 100. Therefore, this is 80 degrees, right? So that is about X, Y, Z in this example. Okay. So next property they want you to look at is the adjacent angles. We have looked at opposite sides, we have looked at opposite angles. Now what can you say about the adjacent angles in a parallelogram? They are supplementary. How can you prove that? If you look at this figure, they have given a parallelogram ABCD here, right? If I call this X, okay, I'm going to extend this side, okay, then this becomes X, right? And I know that this is parallel to this. If BC is my transversal, this is also X, correct? Now these two are X, and what does it make this angle? Because it's a linear pair over here, it is 180 minus X. That means adjacent angles are supplementary. By supplementary, we mean sum of these angles is equal to 180 degrees. Now, this is the third property in the parallelograms. So here they have given another example. They have given only one measurement and they want us to find all other angles. Clearly, if R is 70, N is also 70. And if R is 70, the adjacent angle is 110 because it's supplementary. And because this is 110, G is also 110 because opposite angles are equal in measure. So that is about the example, solved example. Now they have asked us, after measuring R and 70, can you find I and G by any other method? So let's go back to the figure. They're saying R and N are 70 degrees, right? In order to prove that I and G are 110, in order to find out, we have used the property of supplementary angles, right? Now they're saying, can you prove it using any other method? So here, let's say alternate. What is the alternative? So here, the sum of the angles, one of the methods I can think of is sum of the angles in a quadrilateral, okay, is 360 degrees, okay. So sum of all the angles, sum of all angles in any quadrilateral, actually, in any quadrilateral, not just parallelogram, in any quadrilateral is 360 degrees, okay. If sum of all angles is 360 degrees, okay, I already have, I'm going to draw the figure again. I have this as 70. Let me take this as x. If this is x, this is also x. This is 70 and 70, right? So that means that 70 plus 70 plus x is equal to 360. This means that x is 360 minus 140 is 220. 220 and I have 2x here. 220 implies x is equal to 110 degrees. This is another alternate method to find out the other two angles. There is another way as well, which is actually very similar to this, but if you're not comfortable with 360, let me draw the figure again. This is my parallelogram, right? Join this diagonal, okay? If this is, let's say, A, this is 70 minus A, right? Because this entire angle is 70. Now, if this is A, I know that this is A, interior opposite angles. If I consider R, N as my diagonal, right? So this is also A, that makes this 70 minus A. Now consider this triangle RIN. Sum of all angles in a triangle is 180 degrees. Sum of all angles in a triangle. So here, if you consider, we'll write it over here, RIN, triangle, okay. The sum of all angles of a triangle is 180 degrees, right? So that means that if I add A plus 70 minus A is 70 plus this angle 70 plus this unknown angle x is 180 degrees, which again gives us the same result, right? That x is equal to 110 degrees. Okay, so that is the solved example. Next we come to diagonals of a parallelogram. Okay, saying that they are saying that diagonals of a parallelogram are not of equal length. Clearly you can see that, but there is an interesting property over here and they want us to look at that property. So let's go back to our cutout here. I have they're saying let's take one parallelogram, okay, and if you get the midpoint, if you look at the midpoint by folding, right, it coincides with the point of intersection of the diagonals. That means that the diagonals are bisected. Let's look at that. Now see here, how do you get the midpoint without any measurement, without using any scale? You simply overlap this opposite vertex. Okay. When I overlap the opposite vertex, okay, and make sure that if I take it on this side, for example, make sure that I make a crease, okay, at this point. Now, what is this point? This is the midpoint of this line. When I'm overlapping the opposite vertex, I am folding the diagonal. When I'm folding the diagonal, okay, what do I get? I will get the midpoint at the crease, right? Now you can see here clearly that whatever point I have got, it is the same as the point of point of intersection of the diagonals O dash, right? So that is what they're saying. Let me read it out once. Take a cutout of a parallelogram ABCD and use the diagonals. They will intersect at O. Find the midpoint by a fold. What they mean by this is what we have done just now, and you will get the midpoint. You will see that the midpoint of the diagonal by folding, paper folding, is the same as the point of intersection of the diagonals. That means that AC is bisected at O, right? So what can we conclude from this? That the diagonals of a parallelogram bisect each other, okay? That is my fourth property. The diagonals of a parallelogram bisect each other. Now, can you do that using the, the congruency of triangles that we have already proven? They have, here what they have done is, instead of taking the triangle ABC and ABC, what they are taking is triangle AOB and COD. Now clearly these are congruent because 1 is equal to 2, 3 is equal to 4, interior opposite angles in the between the parallel lines AB, parallel lines AB and BC, right? And the other one is AB is equal to CD. So here I have ASA congruency to prove AOB is congruent to COD. Please make sure that we have to write the corresponding sides. The A is corresponding to C here, right? So AOB is congruent to COD. Now, if these two are congruent, if I take AO here, okay, AO is opposite to angle 3. Now, angle 3 is corresponding angle 4 here in the second triangle. So, opposite to that, I have OC. That means AO is equal to OC. Similarly, I'll have BO is equal to OD. Therefore, this is the proof by geometry that diagonals bisect. Now, if I have a parallelogram, okay, they have given a solved example. OE is given as 4, HL is 5 more than PE. Now, if OE is 4, what is OP? This is also 4. That means PE in total. PE is going to be 8. And HL, they're saying, is 5 more than PE. Therefore, HL is 13. Right? So, if HL is 13, then OH is half of that, which is 6.5. So with this, we come to the end of parallelograms, and then in the next video, we will be looking at the exercise 3.3. So we have looked at the definition of a parallelogram and the different properties of the parallelogram. We have proved the properties using both the the geometrical proof as well as proof by activity. Okay.